In this video, we will learn how to plug in values to KEQ and to calculate KEQ. So in previous videos, we talked about how to write the equilibrium product constant. It's always in the format of products over reactants, with these coefficients up in front of the numbers for balancing becoming exponents. So if we read this example problem, it says calculate KEQ for the reaction below if the equilibrium concentrations are NO2 has this molarity, 0.0172 molar, and N2O4 has a molarity of 0.0014 molar. So after we write our equilibrium expression, we can plug in those numerical values. So my product concentration was 0.0014 molar, and my reactant concentration was 0.0172. And that too is an exponent. I have to square this. And if it was raised to the third power, you'd have to cube it, or whatever the exponent is, you have to treat it like it's actually an exponent. So I can type this into my calculator, and I got 4.73. Now, by convention, KEQ has no unit. So when we're calculating KEQ, there's no unit. As for sig figs, this one has 2 sig figs. This one has 3 sig figs. And so even if you're squaring it, you have to remember that when you're squaring, it's like that number times that number. So it's 3 sig figs times 3 sig figs, but there's 2 sig figs up here. So I will round that to 4.7. K has no unit. Okay. We can also use KEQ. Given KEQ, we can also solve for one of the equilibrium concentrations. So in this problem, it says at equilibrium, the reaction PCl5 gas turns into PCl3 gas plus Cl2 gas. We are given what KEQ is equal to, and then we are given some concentrations of PCl3 and Cl2 at equilibrium, and we're asked to find the PCl5 equilibrium concentration. How about you pause the video and try to work out the equilibrium expression and what the equilibrium concentration is for PCl5. Okay, so let's come up with our equilibrium product expression. So we always know it's product over reactants. So that is Cl2 and then PCl3 and that's going to be over my PCl5. All of those had one coefficient, so there's no exponents in this particular example. All of them are gases, and so all of them appear in the equilibrium expression. And so I know that I have 0.10 molar times 0.10 molar. Those are both 0.1 molar. That's what that says. And then I'm trying to solve for PCl5, so I'm going to write X there. And that's equal to my KEQ which is 4.2 times 10 to the minus 2. So I'm going to change pen colors. Okay, so we're trying to solve for x, but x is in the denominator of this problem. So we have to bring x into a numerator so that we can solve for it. So we're going to multiply both sides of the equation by x. Then x is now over here in this side of the equation's numerator, but we need to isolate x, and so we're going to divide both sides by 4.2 times 10 to the minus 2. So that my x's cancel out. And my 4.2 times 10 to the minus 2 cancels out. So that simplifies to 0.10 times 0.10 divided by 4.2 times 10 to the minus 2 molar. I don't need to write all the m's though. So my x is equal to, I know that I'm going to be solving for a molarity eventually, so I'm going to add the unit on at the end. So I can type this into my calculator. Whenever you have scientific notation in the denominator, make sure you communicate with your calculator that all of that is in the denominator. So you have 0.23809 molar. This one has a unit. Everything in square brackets means molarity. Now we have to think about sig figs. And so there are 2 significant figures in this problem. And so we will need to round up, and we will get 0.24 molar. Okay,